Hello friends, greeting from Centum Academy. In this video we are going to see how we can visualize the derivative of some standard functions that we have learned. For example, we know that the derivative of sine x is cos x. So how we can see that on a graph. So in this video I'm going to show you that. So let's say we have y is equal to sine x function. You can see the graph of sine x on your screen. Now I'll choose a point A on this particular graph, let's say here, and then I will draw a tangent to this point, to this curve. So I'm going to just draw a tangent at this point to this curve, which looks like this. And let's find out the slope of this tangent. The slope of this tangent, as you can see here, is minus 0.23. Now what I'm going to do next, I'm going to plot a point whose x coordinate is the x coordinate of A and the y coordinate is the slope of this line that you have seen. So here goes the point B, as you can see here in your screen. Now I'll just on the trace for this point so that you can see the motion of this point B as I change the position of point A. So as and when I move the position of A, you would see that B is tracing a path, right? And if I keep on moving this point A on this graph, you will realize that B traces a path which is nothing but the graph of the cos function. So as you can see, I'm moving this point A on this. In other words, I'm varying the position of x coordinate of A and the y coordinate, which is nothing but the slope of the tangent at that point, is getting recorded. And as you can see, the dy by dx versus that x graph will be nothing but it is the graph of the cosine function, and therefore it is very evident that the derivative of sine function is nothing but the cos function, right? So as you can see, this gray line is the graph of dy by dx of sine x. So this graph, this is nothing but your dy by dx, and the graph is that of a cos function. Not only that, we can also find the graphical representation of the graph of other standard functions as well. I can also show you the graph of log x function, whose derivative we know is 1 by x. So let's choose a different screen. Okay, so I'm going to just draw the graph of y is equal to ln x. This is the graph of ln x, and just like the last time, I'm going to choose a point on this, let's say A, and then I'm going to draw a tangent at A to this curve, which is as shown, and then I'm going to plot a point B whose x coordinate is that of A and y coordinate is that of the slope of this line. Okay, so let me just find out the slope first. So slope of this line, as you can see, is 0.31. So the point B will be having the x coordinate of A and y coordinate of the slope. There goes the point B. Let me on the trace for this point. Now I will try to move this point A on this graph, and you can see the path of the point B in gray color. So as I move this, the slope goes higher and higher and higher, right? And let me go on the other side. Right, so as I move the graph on the right side, you see the path taken by point B, and this path as we all know, is the path of the graph y is equal to 1 by x. So the derivative of this is nothing but y is equal to 1 by x. So the derivative of log x function, as we all know, is 1 by x, has been demonstrated in this graph. Hope this makes sense to you. Thank you so much for watching.